Hello, everyone. Hello. We're Unit 5, Lesson 1. Sorry, no music. All right, I'm a little behind here, so I got to get this in. So what we're talking about in Unit 5 is sequences and series. You started Algebra 1, Common Core Algebra 1. You studied some sequences. Now, the key thing, one of the key aspects of a sequence is that it is a function whose set is the set of positive integers. Positive integers. So it's not continuous like a line. So you have your input value, you have your output value, and that's it. All right, I don't have any decimals, any fractions, okay, as input values. You can have them as output values, but not as input, okay? So when we look at, and I don't want to show you all of them, okay? When we look at each term, okay, in the first exercise, usually they'll give you some equation. And they'll want you to find the third term, the first three terms, the fifth term, whatever, okay? So find the first three terms. So when I look at this one, my first three terms, A1, okay? So A1, you always start with 1, of course. You don't start with 0. You start with 1. So 1 goes in for n. And that is usually how it will work. Wherever you have an n, you plug it in. A sub 1 equals 2 times 1 minus 1, which is 1. Now A2, okay, equals A, put 2 in for n, 2 times 2 minus 1 is 3. Now if I go too fast, you need to pause it. Okay, and then we have A3, don't copy this down here and see. A3, which is 2 times 3 minus 1, which is 5. Okay? Now, if they want you to find out which term has a value of 53, that means I want my A sub n to equal 53. So then you put 53 in for A sub n, you have 2n minus 53, and you go ahead and solve. 2n equals 54, n is 27. All right, like I said, it might be a little quicker lesson today, but make sure you pause it where you need to copy things down, okay? Explain will not be a term that has a value of 70. So same thing, you plug in 70 for an. Then you go ahead and solve. And you see when I solve it, I get an n value of 35.5. Remember what I said up here is that the domain is a set of positive integers, cannot be decimals. For, again, input values, okay? Output values can be decimals. So we also talk about, and I know you talked about this in next door, is recursive definitions. So recursive definitions, terms found by operations on previous terms. Okay, so you have to use the previous term to find the next term. So we have our rule. Okay, I'm going to do this. We have our rule for f of n. So f of n is f of n minus 1 plus 5 with f of 1 equaling negative 2. Usually they'll give you the f of 1. Okay, so f of 1 equals negative 2. Done. Find the first 5 terms. Term 2. Okay, term 2. So it's f of 2. So wherever you see an n, see the n's? You put in a 2. So f of 2 minus 1 plus 5 equals f of 1 plus 5. Then you substitute in for f of 1, which is negative 2. Negative 2 plus 5 is 3. Follow it right across. Okay? Now that's the second term. The third term is f of 3. So f of 3, you plug 3 in for your n. You have f of 3 minus 1 plus 5, which is f of 2 plus 5. F of 2 is the previous term, okay? Operation on previous terms. And that is 3 plus 5, which is 8. F of 4, okay, you have f of 4 minus 1, okay, which plus 5, which is f of 3 plus 5. F of 3 is 8. 8 plus 5, 13. And then the last one, f of 5, is f of 5 minus 1 plus 5, which is f of 4 plus 5, which is 13 plus 5. which is 18. Okay? So there's your recursive definition. You're using your previous term to find the next term. Now, determining the value of f of 20 and b, how many times do we have added 5 to negative 2? So you see how all of these here are going up by 5. They're all going up by 5. And what we did is we started with a negative 2. So to get to f of 2, I added 1 5. To get to f of 3, I added 2 5s. So to get to f of 20, I would have to add 19 5s. It's always one less. Well, usually one less. And that will give you 93. Okay? Now the next one, and this is not uncommon. You might have to determine the recursive definition. So if they want the recursive definition, it says, see here it says be sure to include the starting value. So my starting value is f of 1 equals 5. Now what you want to do is you want to look at a relationship. All right, you want to find a pattern. You did this probably in middle school where you're finding patterns and find the next 3 values in the pattern. So from 5 to 10, what's going on? From 10 to 20, what's going on? From 20 to 40, what's going on? Now, sometimes what will happen is you can have multiple rules for the first couple, but then as it goes further out, the rules will eliminate all your possibilities until there's only one possible outcome. So to get from 5 to 10, sure, I can add 5. Okay? To get from 10 to 20, if I add 5, no, it doesn't work. To get from 5 to 10, I can double it, multiply it by 2. Yup, that works. 10 to 20 multiplied by 2, yes, it works. 20 to 40 multiplied by 2, yes. So what are you doing? You're taking the previous term and multiplying it by 2. So that is your definition. F of 1 equals 5, f of n equals f of n minus 1 times 2. Now, in exercise 4, you want to find the value of t of 4. So t of 1 is 2, and I'm just going to have this all right here for you. So, unfortunately, you will have to show each output. You have T1, then you have to do T2, T3, T4. There's no simple way to get to T4. And don't skip the steps. Take the time and do this, because then you will arrive at the right answer. If you skip steps, if you don't show me something, that's where you're going to make an error. And they know where you make your error. That's why they have these 4 choices, and they're all probably an error that a student will make. And you'll be like, oh, I got the right answer, but it's really not. So you can see T sub 1 is 2. T2, again, the 2 goes in wherever you see an N. It's usually an N, not always, but usually an N. So you have your previous term. T2 minus 1 is T1, which is this 2 right here. 2 squared plus 2. 4 plus 2 is 6. Now the next one, you have T of sub 3. So the 3 goes in for the N, so you're looking at the previous term, okay, which is your 6 squared plus 2. So 36 plus 2 is 38. Again, I go too fast, pause it. Okay, make sure you're getting it all down. And then T4, don't be scared of numbers getting larger. Remember, exponential growth. If you're squaring things, if you're raising it to a power, it'll go up much quicker than a linear. And our last one, the T sub 4. T4 minus 1, right here, squared. So that is T3, which I have right there. Oh, I didn't put it in. So T3 is 38. So that's 38 squared plus 2. So I'm doing the calculator, and you get 1446. So it says just the T4, which is your 1446. Okay? I only got a few minutes left, so here I thought it was going to be a quicker one, and I don't want to lose you here. So here we have what is called a Fibonacci sequence. Okay? So with a Fibonacci sequence, they use 2 previous terms. Okay? So you can see our definition right here. I know some of you are already copying down, which is fine. You might have to pause this one. So you have f of n minus 1, which is the previous term. N minus 2 is 2 previous terms. That's why they give you f of 1 and f of 2. So you can see that f of 3, and I showed it all out, f of 3 minus 1 plus f of 3 minus 2 equals f of 2 plus f of 1, which is 1 plus 1. Okay, f of 4 is f of 4 minus 1 plus f of 4 minus 2, f of 3, f of 2. Okay, so pause it, copy it down. All right, come back, I'm moving on. Okay, now with the next one, time constraints, right? Remember, you want to find the algebraic formula. So your set will be 1, 2, 3, okay, for your n values. Now, you look at the numbers, 4, 5, 6, 7. You should be able to clearly see in some instances, especially this one, what's going on. So my first value, okay, the domain has to start with 1. We have to start with an input value of 1, okay? So just like up here, we had f of 3, you put the 3 in, but we already knew 1 and 2, okay? So 1 to something gives me 4, okay? And then, well, this will work for each one, okay? So, wow, I don't know how I'm getting colors here, all right? So 1 plus 3 is 4. If you put the 2 in, 2 plus 3 is 5, okay? 3 plus 3 is 6, but they're not always that easy, okay? So to find what is going, why can't I pull this up, okay? All right, so to find what's going on here, you put 1 in for n, and 1 plus, minus, divided by, whatever, some value gives you a 2. Okay, so I can do plus 1, or times 2, fine. Next one, 2 times some value gives you 4. Can't do plus 1, gives me a 3. Sure, I can do times 2, gives me a 4. Works just fine. Next one, 3 times 2, nope, it doesn't give me 8. Okay, so you see how you can have multiple rules here, you eliminate a rule here, it doesn't work here. Okay, so what happened was you are raising it to the n power. Okay, 2 to the n power, 2 to the first power is 2, 2 squared is 4, 2 cubed is 8. Okay, so these are where you need to know your bases, what's going on. Okay, now look at the next one, letter C, the denominators. You see, this one is technically over 1. Okay, so you see you got 1, 2, 3, 4. Well, that one should be kind of easy, right? Because you're just going up with your domain. So, and this should be a 2, not a 1. That should be a 2. So what do you have there? You have your an equals 5 over n. Okay, because your n, remember, is 1, 2, 3, 4, 5. Now, this one here in letter D, this is a rule that you see quite a bit. Oh, where'd you go? Okay, so whenever you see them alternating positive to negative, what happens is you have a -1 raised to the n power. It's what will happen. Okay, and we'll talk about that more when we get into it. Letter E and F, okay, I'll show them so you can copy. N equals 1, so 1, so some value gives me 10. So I can maybe do times 10. Okay, but then I do 2 times 10, doesn't work. Okay, so it gets a little more involved. But you can see that these are going up by 5. So that's where I'm adding 5. Okay, so what do I add to 5 to get 10? I add 5. 5 times 1 is 5. 5 times 2 is 10. Okay, so 5n plus 5. If you need more explanation, ask me in class. Letter F, you have to realize 4, 9, 16 are perfect squares. You got to realize that. Okay, it's got to jump out at you. So 1's all on the top. So there's my rule. an equals 1 over your n squared. Okay, and this is the last one, I think. Yep, this is the last one. Okay, so which would represent the graph of the sequence an equals 2n plus 1? It is not a line. The domain only includes 1, 2, 3, 4, and so on and so forth. Okay, so they're not connected. You can't have decimals. So therefore, well, this one can't work because you don't have 0. So it's got to be this one. Because my input has to start at 1, 2, 3, 4, on and on and on. Okay, so that's why it's choice 3. So sorry, the short video turned into one of your longer ones. Hopefully, I know I had to go a little quicker at the end, but any questions, see me in class. All right.